Okay, so on the previous video, I talked about what a log is and where it comes from. And we came up with this formula at the very end. If you have an exponential equation, b to the x equals a, and you want to solve for x, x is equal to the log base b of a. And these are one and the same, right? You can work from an exponential equation, change it to this log, or you can take this log and change it back to this exponential equation. So one of the first things you probably will be expected to do with logs is just evaluate a log. So the log base 7 of 49, and to evaluate a log, if you're not sure how to do it, you can always rewrite it into exponential form. Now, one thing that's missing here, of course, is x here. And so they're usually written like this, but you could think of it this way. We don't know what the log base 7 of 49 is yet, so let's call that x. If we use this as a guide, then the exponential equation that goes along with this would be my base 7 to the x equals 49. And then it's, oh, that's pretty easy. X would be 2, would be my answer. So the log base 7 of 49 equals 2, which then brings up the other way to think about this. Remember what a log's really asking. Why is this answer 2? It's because when you see the log base 7 of 49, what it's really saying is what power of 7 equals 49. That's what you, and oftentimes if you know how to read a log and ask yourself that question, you can answer log questions without doing any work. Not always, but sometimes. So for example, on my next one, log base 5 of 125, what is that really asking? It's saying what power of 5 gives me 1 over 125? Yeah, it might be a little bit harder. But if you think about what power of 5 gives me 125, which would be 3, to get 1 over 125, it would have to be 5 to the negative third power. So the answer to this is going to be negative 3. Now, if you're ever unsure with that, of course, we can write this out in exponential form. This says 5 to the x equals 1 over 125. And then if you realize this is really 1 over 5 cubed, which could be rewritten as 5 to the negative 3. When you get it at this point, we could just argue that if 5 to the x equals 5 to the negative 3, what does x have to be? X has to be equal to negative 3. Okay. It's not that you're dividing out or canceling out the x's or anything. It's just this idea that if you have an equation with the bases are the same, what must be true is my exponents must be the same. Let me write that down. If the bases are equal, then my exponents are equal. Okay, so it's not, again, it's not that you're dividing out the 5. That's not really what's going on there. Okay, let's try a couple more. Log base 13 of root 13. If I ask myself, what is it saying in words? It's saying what power of 13 gives me the square root of 13? Perhaps just saying that, you might know the answer. If not, we can always write this in exponential form. And at some point, you do have to realize then that the square root of 13 really is, recall fractional exponents, that's 13 to the 1/2 power. So once again, my bases are the same. That means that x has to be equal to 1/2. Okay, now this next one, log base 9 of 9 is basically saying what power of 9 gives you 9, or in exponential form, 9 to some power gives you 9. Well, what's the power of 9 that gives you 9? It's got to be 1, huh? 9 is 9 to the first, so x would be 1. And, you know, sometimes you see one like this, you kind of learn from that, you know, any kind of log that you have, if you have the same base, like if I was doing the log base 17 of 17, For the same reason, that's going to be 1. If I have the log base 5 of 5, that's going to be 1. Remember our special bases too. If I have just log of 10, and remember that our invisible base when we have a log with no base written is 10. It's like saying what power of 10 gives me 10? Once again, that would be equal to 1. One more, remember that our other special log is the natural log. If I saw the natural log of e, knowing that there's an invisible base e there, it's like saying what power of e gives me e? Same deal. That's going to be 1 as well. So yeah, anytime the bases match up with what you're taking the log of, that answer is always going to be 1. All right. How about the log base 9 of 1, which is asking what power of 9 gives me 1? Well, we're not going to make the bases the same necessarily. Well, we could, I guess, but just think about what power do you raise any non-zero number to get 1? That's got to be 0. Again, you could generalize this. Hopefully you can see that it doesn't matter what base you're dealing with. If I was doing the log base 3 of 1, what power of 3 gives me 1? That's going to be 0. If I was doing the log base 7 of 1, that's going to be 0. If I was taking the log of 1, that's going to be 0, right? Because whatever your base is, that to the 0 power will always give you 1. The natural log of 1 is going to be equal to 0, etc. What about 0? If I have the log base 9 of 0, and I'm trying to figure out what makes that true, 9 to the x equals 0, some power of 9 that gives you 0. If you're struggling, it's not 0, right? Because 9 to the 0 is 1, we saw. So it's not 0. And if you're struggling to think of a power, it's because there isn't one. There is no power of 9 that you could raise to and end up getting 0. This has no solution. And for the same reason, no matter what your base is, if you try to take any log base of 0, you're going to be basically trying to answer this same question here, and you're not going to have a solution. So this is kind of important here. What we could say then is, remember this number right here, we refer to that as what we're taking the log of. And what we learn from this is you cannot take the log of 0. Any base cannot take a log of 0. That's not going to work. What about, whoops, too far, here we go. What about trying to take the log of a negative number? If I tried to do the log base 9 of -9, which says 9 to some power is supposed to come out to be -9, be careful, it's not -1, right? Remember that 9 to the -1, I'll put this over here, is not -9, that's 1 over 9, right? So it's not -1, and in fact, there is no power you can raise +9 to and get a negative number. So this also would have no solution, and it would be true no matter what my base is. So another thing that we have to keep in mind is we can never take the log of a negative number as well. Can't take the log of 0 or a negative number. Cannot take log of a negative number. All right, let's try this one. I'm not taking the log of a negative number or 0. So I've been saying that sometimes you can answer the log question by just reading out in your head what it's saying, which is 9 to some power. What power of 9 gives me 27? Be careful, it's not 3. 9 times 3 equals 27, but not 9 to the third power. And that's not obvious, right? Off the top of your head, you may not know what power of 9 gives you 27. So that's why it's helpful to know you can write this out. 9 to the x equals 27. And the idea behind solving this is what we did on a previous problem is to try to make both sides of the equation have the same base. You'll notice that 9 and 27 are both powers of the same number, which is 3. 9 is 3 squared. 27 is 3 cubed. So, and then what do I do when I have a power raised to a power? I'm going to multiply those powers. So that is the same as 3 to the 2x equals 3 to the third. And then that idea that if my bases are the same, my exponents must be equal. So I know that 2x has to equal 3. X will be 3 halves. Let's try one more. Okay, so what power of 16 gives me 1/8? Yeah, I don't know. So I'm going to write this in exponential form. 16 to the x equals 1/8. And then you want to try to think about writing both sides with the same base. Both 16 and 8 are powers of 2. So that would be what you'd want to do. 16 is really 2 to the 4th. 8 is 2 to the 3rd, which means 1/8 must be 2 to the negative 3rd power. This becomes 2 to the 4x. And once again, I have my bases equal, so I know that my exponents must be equal. 4x has to equal -3. X is going to have to be -3/4. Okay, if you're watching this, you might want to pause the video and go ahead and try number 10 on your own. It's kind of the same idea as the last two. All right, assuming you've tried that. What the exponential form for this, 1,000 to the x power equals 100. And what number could I write both sides in terms of? What base? I could write those are both powers of 10. 1,000 is 10 to the 3rd. 100 is 10 squared. This gives me 10 to the 3x equals 10 squared. So since my bases are the same, I know that my exponents have to be equal to each other. 3x equals 2, which gives me the answer of 2/3 for x. And then one final one here, just you got to get comfortable with natural logs and working with, remember, the base of a natural log is the number e, which is about 2.7. We don't usually write it, but know that there is an invisible base e there. And my exponential form for this one is e to the x equals the inside, which is e root e. This is not the eth root of e. If I wanted that, I would have made the e a little bit smaller. This is e times the square root of e. And so using our strategy of trying to make the bases the same, the right side is the same thing as e times e to the 1/2. Of course, e is just e to the 1st, right? Just to emphasize that, because what do I do with the powers when I'm multiplying? I add them. So the right side is e to the 1 plus 1/2, which could be written as 3/2. X in this case would equal 3/2. Okay. So those are some examples of how to evaluate logarithms.